Hi, I am Madam Rosmaya. Welcome to my YouTube channel. I am a pre-U physics teacher at SMJK Yuhua. In this video, we are going to discuss on centripetal force in circular motion. So we are going to derive a formula for centripetal force. When a body is in circular motion, it accelerates towards the center of the circle. According to Newton's second law, F equals to ma, the body is able to move in a circle due to action of the resultant force in the direction of the acceleration, which is towards the center of the circle. The resultant force acting on a body in circular motion towards the center of the circle is known as the centripetal force. Centripetal force F equals to ma. We can substitute the centripetal acceleration from the previous video in circular motion part 2, where we get A equals to V omega, or A equals to R omega squared, or A equals to V squared per R. So if we substitute V omega, we get F equals to mV omega. And we can also substitute R omega squared into A here. We get mR omega squared. And finally, if we substitute A equals to V squared per R into the equation, we have mV squared per R. So this is the equation for centripetal force. So the direction of the centripetal force is towards the center of the circle. And the direction of centripetal acceleration also towards the center of the circle. The centripetal force acting on a body in circular motion could be provided by tension in the string or friction between a car and the road. So example here, when the car move in circular motion at the roundabout. And also centripetal force could be provided by the gravitational force between the moon and the earth. So the type of force that provide the centripetal force depends on the situation. No work is done by the centripetal force because it is perpendicular to the direction of the displacement. So we are going to discuss one example each for horizontal circular motion and vertical circular motion. Okay, for horizontal circular motion, in this example, we are going to discuss a conical pendulum. So it is formed when a bob of mass m at the end of a string L is whirled in a horizontal circle of radius r less than the length of the string. Let's say the length of the string L and the angle to the vertical is theta. So it make a circular motion, horizontal circular motion here. So the force act on the bob is tension in the string and also mg. Let's say the radius of the circular motion made by the bob here is r. So the centripetal force F, there are three equations. So let's say we choose the middle one, F equals to mR omega squared. So the centripetal force is provided by the tension component, horizontal component of the tension, T sin theta. So the component of T is T sin theta and T cos theta. So the T sine theta provide the centripetal force. So we equate it to mr omega squared. If r is not given, we can calculate from the triangle here, where we get r equals to L sine theta. So we use trigonometric ratio. From this triangle, theta L and R is given. L and R is given. So sine theta equals to R per L. So therefore R equals to L sine theta. Okay, then we can substitute into the equation above. So therefore, we get ml sine theta omega squared. So sine theta can be cancelled out. So we get tension in the string equals to ml omega squared. So this is the first equation. We get from the centripetal force. Okay, next we are going to determine the equation 2. Where the t cos theta equals to mg, because the pendulum is moving in a conical circular motion. So the vertical component t cos theta is equals to the mg. So the pendulum here does not move up or down, so it maintains in the horizontal circular motion. So therefore t cos theta equals to mg. So this t from equation 1 can be substitute into equation 2, and we can cancel out m. So we can get angular velocity omega equals to square root of g per L cos theta. So this is angular velocity for the horizontal circular motion in conical pendulum. Next, we discuss one example on vertical circular motion. Example is in this Ferris wheel. So the figure shows a Ferris wheel which has a diameter of 135 meter and takes 1.0 minute to complete a revolution. A person of mass 52 kg takes a ride on the Ferris wheel. So calculate the angular velocity and the speed of a basket of the Ferris wheel. So we are given diameter d, and then period t 1 minute, and the mass of the person in the basket of the Ferris wheel 52 kg. So to calculate the angular velocity, we use formula omega equals to 2 pi f, and f is equals to 1 per t. So the t given is 1 minute, convert to second, 60 second. So 2 pi per 60 second give the answer 0.105 radian per second. So this is angular velocity. Next, we are going to calculate the speed of a basket. So speed of this basket is v equals to r omega. So we substitute r given, which is 135 divided by 2, because this is diameter. So 135 divided by 2, and angular velocity from question I, we get 0.105. So the answer for speed is 7.09 meter per second. Okay, next question. Show on a diagram the forces on the person when he is in basket A and to basket B. Hence, calculate the reaction of the basket on the person in each of the baskets A and B. So for basket A, the forces that act on the person is weight of the person, mg, and also the reaction normal reaction, the person act on the floor of the basket. So let's say we name the reaction as R1. Centripetal acceleration is directed towards the center of the circle. So therefore, from Newton's second law, F equals to ma. So the resultant force in this case is R1 mg minus R1. So we follow the direction of centripetal acceleration as a positive. So mg is positive, R1 is negative, and equals to m. Let's say we choose centripetal acceleration A equals to V omega. So therefore, R1 equals to mg minus mv omega. Factor out m, bracket g minus v omega. And then we can substitute mass of the person, 52 kilogram. G is 9.81. V, 7.09 times angular velocity, 0.105. So therefore, the reaction at basket B is 471 Newton. Okay, next we are going to calculate reaction by the person on the floor of the basket B. So at basket B, the force act on the person is mg, weight of the person, and the reaction upward because by the floor. So we name this reaction as R2. Because A direction is towards the center of the circle, A is centripetal acceleration, so therefore R2 is a positive and mg is a negative. So the centripetal force is provided by the R2 and mg, so becomes R2 minus mg, so equals to mv omega. And R2 equals to mg plus mv omega. Factor out m, so bracket g plus v omega. So substitute m, 52 kg. G is 9.81 plus v, 7.09 times 0.105. So the answer is 549 Newton. So the reaction, normal reaction at basket B is larger than normal reaction at basket B. Okay, so the end. Thanks for watching. That's all for the video.